Have you ever wondered how screws, bolts, or threaded components achieve such precise and uniform grooves? Behind these perfectly engineered threads lies an advanced manufacturing process, CNC threading. CNC threading is the process of cutting or forming helical grooves on a workpiece using computer-controlled cutting machines. Thread terminology. Let's understand what a thread is. Crest, the top of the thread ridge. Root, the bottom of the groove. Flank, the angled surface between crest and root. Pitch, the distance between thread peaks. Major and minor diameters, the outer and inner limits of the thread. These features determine how well a thread fits and functions in your assemblies and fasteners. External and internal threads. External threads are cut on the outside of a component, like a bolt. Internal threads are cut inside a hole, like in a nut or housing. CNC threading processes. Single-point threading. Single-point threading uses a carbide insert or tool with a precise thread profile. On a CNC lathe, the tool moves axially along the workpiece while the spindle rotates. The feed rate must exactly match the thread pitch, allowing the tool to trace the helical path and gradually deepen the thread over multiple passes. Thread milling. Thread milling uses a rotating tool that follows a helical interpolation path. The tool can enter and exit the cut smoothly, producing accurate threads without the need for spindle synchronization. It's ideal for large diameters, blind holes, or special thread forms. Tapping. Tapping uses a fixed geometry tool to cut internal threads in a single continuous motion. The tap follows the hole center line, and the spindle rotation is matched to the thread pitch, ensuring accurate lead. Thread forming. The thread forming process doesn't remove material, it displaces it to shape the thread profile. This produces stronger burr-free threads with excellent surface finish and eliminates chip evacuation problems common in cutting. Steps for CNC machining threads. G-code. The threading cycle begins with precise programming. G-codes like G76 or G32 control the spindle speed, depth, and synchronization for accurate threading. Cutting passes. The tool makes several controlled passes, gradually reaching the final thread depth while maintaining pitch accuracy. Finishing a final smoothing pass may clean the crests and improve surface quality. Tolerance checks. Go, no-go gauges or thread micrometers ensure the threads meet strict tolerances for fit and performance. CNC threading provides high precision and dimensional repeatability, faster, automated production cycles, flexibility for complex or custom thread geometries, consistent quality across large batches, reduced manual error and rework, stronger and cleaner threads when using forming techniques. If you'd like to learn more about threading techniques, CNC programming tips, and advanced machining processes, be sure to explore our other resources and guides.